Network Automation Nerds podcast. Hello and welcome to Network Automation Nerds podcast, a podcast about network automation, network engineering, Python, and other interesting technology topics. I'm your host, Eric Cho. Today on the show, we'll be talking to Alex Saroyan, CEO and co-founder of Netris.ai. Prior to co-founding Netris, Alex held roles at UCOM, Orange Telecom, Lycos Europe, and many other places. We'll be talking to Alex about his journey in founding multiple companies and all the cool projects that he has worked on and the products and features of his current company, Netris. Alex, welcome to the show.
Hi, Eric. Thanks for having me. Very excited to be here.
Yeah, I mean, it's great to have you on the show because I think what you're working on and what your projects within Netris is so relevant to kind of the audience for the show. I think it's almost like, hey, why did I wait too long? Mainly because I didn't really know of the existence until I hear you talk on Art of Network Engineering, and I'm sure some of our audience have heard you about your background story at Art of Network Engineering. But for those people who haven't, can you just tell us a little bit about yourself and how you get into technology, how you get into network engineering?
Sure. So I loved tech since my childhood. Loved computers, and I'm grateful that I got my first computer when I was, in maybe 5th, 6th grade, and I was going to this place where they were teaching kids to program, and back then you had to program to be able to play something. That's how I got into computers. And during school, when I was at high school, I was already very much into Linux and networking. And right after high school, I started kind of sort of building my career in network engineering. So just like many of network engineers, I've started just by learning Cisco commands, like typing in commands into Cisco CLI, and I knew how to program, and I've improved my programming skills over time for the just to start automating my regular network engineering things.
Right.
And over time, I've embraced software-defined networking and APIs, tried to do things with those constructs. But moving forward, I've seen how public cloud is defining kind of new standard user experience for DevOps engineers, and I always thought about DevOps engineers, application infrastructure engineers as of my customers, because what I was doing as a network engineer, I was managing this team of network engineers, and people were other teams were asking us to provide them network resources, to create a VLAN, to provision something in new rack. So those people, those application and infrastructure engineers, they were our customers, right?
Right.
But when I have seen how public cloud is servicing some of the same customers, I was like,
you have competition.
this is how it's supposed to be. That's
Right.
how the idea of starting Netris, was born.
Right. I mean, that was kind of interesting when you mentioned you started out programming and you had your first, kind of Linux experience back in, I don't know, you said 5th grade, right? So I think that's kind of interesting you mentioned it because a lot of times we hear like the two extremes of how people get into technology. One is like they start really, really young. They, program their first game when they were 5 years old, and so the game when they're before they graduate elementary school, right? And then we have another spectrum where people didn't really touch or didn't even really know networking existed. They thought networking was just something that always worked. Internet has always been there. And then they worked backwards, right? Like they enjoyed their food of social networks and then came back to networking. So you were kind of in the first camp where you started young and you knew this is what you wanted to do. And you, with that background, you went into networking. Yeah, so
Yep.
that was kind of interesting. But I, because of that background, I'm always curious for people who are went down that path. How did you feel when you first look at this domain specific language that's called Cisco iOS, right? Like, did you think, oh my God, this is so restrictive. I could do so much more things if it just gave me APIs or SDKs, or what were your thoughts when you first beginning to learn networking and you're kind of restrained into the iOS environment?
Oh, that's a great question. So uh, I happen to uh, embrace these two worlds at the same time,
Hmm.
Linux world and Cisco iOS world, and they these both worlds were amazing. And back then, like 20 years ago,
Hmm.
Linux was this world of you know infinite possibilities where you can like use anything, create anything, modify anything. And Cisco iOS was this another world where everything networking is what was there. Because of the performance issue, you would not be able to get the same performance in Linux, although you could do networking in Linux, but the performance wise, Linux networking was prohibitive back then. So I
Right.
had these two worlds, and over time, you know, each world was missing something. When in Linux world, I
Right.
was missing this network performance, and
Right.
in networking
Right.
Cisco CLI world, I was missing this
Flexibility.
uh, flexibility of like doing anything, like creating something.
Right.
And uh, when I have embraced public cloud, when it evolved and I have embraced, I've discovered this third world, which was kind of a world of infinite flexibility and immediate provisioning, self-service.
Right.
So uh, and then open networking started to show up with the like Cumulus Linux. They were one of the open networking operating systems, and
Absolutely.
that and yeah, I started to think about Cumulus Linux that this is Linux for networking devices, for switches. So basically, this will enable creative people, developers that are into networking to develop and create new functions, new features on the switch, which wasn't possible in a Cisco world.
Yeah.
That was another kind of signal for us that time is now, because we knew, okay, public cloud is the example of experience
Right.
that needs to be everywhere, not only in public cloud but also on premises. And possibility to run Linux on the switches is this enables people to develop programs that are running literally on the switch. And
Right.
and also regular Linux, it also evolved, and we have seen rise of smart NIC cards,
Yep.
DPDK acceleration, eBPF, and those technologies again, they were bringing performance closer to the Linux and flexibility of development closer to networking hardware, and the
Right.
need described by public cloud. So these three things kind of were like, hey Alex, knock knock. You need to do something.
Alex smells the opportunity. Yeah. So no, I totally get what you're saying, right? Like because you had previously, I mean, it wasn't even Linux, right? It was like BSDs, and you have your AT&Ts and your Sun Solaris who were banking on this, this world of, they weren't even open source. I don't think they were open source. So so Linux was kind of this newer kid on the block, and you could do anything. You have all the look and feel of BSD and Unix, but you have the flexibility of open source and the GNU tools and all of that. However, the problem, yeah, you mentioned before was you could stick multiple NIC cards on the Linux and make it a de facto router, but you would never get that FPGA performance, right? Like you can never program that fib that would route the packet as fast as you could. On the other hand, you have the Cisco device where you throw in all the vendors you want, Juniper, Cisco, whatever, then they could route the packets really, really fast. But then on the management front, you're in their wall garden, right? Like, yeah, it's Juniper is the BSD on the back end, but never to open up that kernel to you. You can't just install I don't know, Vim onto the box. So
Yeah, exactly.
yeah, and then the public cloud came around, and so that was like the third leg where you saw. And no, there's so many things that you talked about I could identify with. You're talking about Cumulus having this natural bridge between Linux kernel. I mean, we had Dinesh on a few episodes ago, and he talked about what Cumulus was doing, just making the shim, right? Like whatever you type into Linux, your terminal, then they make this shim that translates into like the lower level commands that they could execute directly on the box itself, whatever white label that they were using. So no, everything you talked about is like I was just nodding my head. Like if I nod my head even more, my chin is gonna fall off. So interesting that you mentioned all these stuff that I was just like, yeah, that's right. But the difference was, right, like the difference between you and me is you saw that opportunity and you went ahead and found Netris, and I didn't. I'm here talking to you. So tell me, Alex, what you talked about these signals, right? But how do you go from signals into making this a reality?
So we were. But I have already experimenting with few things um, around like back then I was trying to do something kind of parse the console or analyze the console output and kind of make network engineers' life better.
Yeah.
But when I've noticed the signals, I decided to kind of change the approach. Before that, I was trying to kind of innovate on existing stack. And after seeing these signals, it was like this new idea struck my head. And all of a sudden I thought this way, like, hey, we don't really need to operate on principles and approaches of traditional networking. Public cloud, it's very much different. It's very much prescriptive in so many cases. Like you cannot decide what protocols they should use under the hood, right? These type of things are being decided by the software running under the hood of the cloud automatically.
Right.
And what is left for engineer to decide are things that are we humans are good at, like designing the networks, deciding how do we connect our different data centers, how many data centers to create, like really architectural things. And so I thought further, like, hey, our minds, human mind is good for this type of architectural things, for creative things, but everything that is kind of repetitive and it's not really a rocket science can be handled by software. And if it is handled by software, if it is the entire configuration is generated by software, software, following human defined requirements and policies, but like what if we take away that human typing command component from the whole process? We definitely gonna benefit from human error perspective. We're gonna improve the consistency, because looking into our traditional network engineering history, we know that most of the failures are related to inconsistencies. I configure something, my colleague configured something else a little bit different, and I come back and manage his configuration. I
Right.
screw things up, right? And
Yeah.
network blows out.
Yeah.
We can't afford that when we are providing self-service situation. We want to give DevOps engineers the opportunity to self-service, but we wanna do this in a safe way. We can't let them break the network. So an important component in that whole thing was software needs to configure everything. And my co-founder and I, we did a couple of experiments. Like we picked a couple of basic use cases that most of every data center is doing that, and we have created kind of prototype and tried to find the first adopter. We thought, like, if this is a thing, we should be able to find at least one company who will deploy this, who will give this a shot.
Right.
So we found first two adopters, and they agreed to try our prototype.
Mm-hmm.
We've learned a lot, and we've seen a lot of issues in our first versions of algorithm.
Sure.
But we have seen, what we have noticed, that it is not impossible. So
Right.
basically, listening to their feedback, we've improved the core part of the algorithm, and it was kind of proof for us that the idea can work. That was kind of internal validation, and we decided to kind of start building on that.
Oh, that's cool. That's cool. So you actually went ahead and did a minimal viable product, of course. Then you validated that idea with two customers. Were they paying customer, or were they just they graciously agreed to test that out because they like you so much?
So well, having prior relations with this with this early adopter
Adapters.
customers
Sure.
definitely helped a lot.
Hmm.
And I'm grateful that they trusted us,
Yeah.
team of few people
Right.
experimenting something. And so what the agreement was this, that they will try, if it works, if it gets to the point where it's something that they can like trust, and kind of start moving their commercial customers to that new technology. At some point, they will start to pay.
Right.
We are grateful that during this experimental time, they let us to do all the experiments, and they handled all the pain that came with all these experiments.
Right. Right.
But eventually, we went into production with both customers, and eventually they became our first paying customers.
Nice. Very cool. I mean, of course, they have to trust you. They have to have some kind of confidence, and that you guys jointly take that risk, right? Like it's risk on your part, risk on their part as well. But they could see the potential of, what if this works? Then down the line they could see the potential. So it was definitely a calculated risk, and I'm glad it worked out for you, because a lot of people, I think there's a lot of people trying out the MVPs in different ways. Maybe they're more academic, so they try it out in like a school network, like what OpenFlow did, right? Like you try it out in Stanford, and just in a less pressure environment, and some of them try it out with internally. I think there was a few projects where I don't know, internally Google, for example, right? Like they Kubernetes, right? Like they did it for themselves, tried out and validated internally. And because the company was big enough that they were able to get enough experience, so even before they released the beta, they were very well versed in the different use cases and breakage scenarios. So this would be like kind of a more traditional way, I would say. So you put out a product, you find one or two personal relationship customers, and you try it out with them. So can you tell? That's a good segue into my next question is, can you tell us what is the problem? I think you dive into a little bit where you say you look at these other developers as your internal customer, right? Like you're trying to service them because your competitor, if you don't service them well, your competitor, which is, Amazon AWS and Azure, they could just go away, put in their credit card and launch a few VMs and VPCs, right? So can you tell us what the problem Netris is trying to solve?
So you can tell that public cloud is successful and growing pretty well.
Yeah, I can tell. I was with Amazon at the time. I was dying, right? Like we're dying and trying to keep up with the demand. Like we couldn't build data centers fast enough.
Yeah, so there's a reason for that.
Yes.
It's 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 convenient, and for most of the businesses, they don't really need to be kind of they don't really need to manage the infrastructure. Before public cloud, a lot of businesses they were forced to manage the infrastructure because there was no other way.
Right.
With the introduction of public cloud, there was new concept. You still can run your applications, but you don't need to manage your infrastructure. You don't need to think about power cooling and network configuration and server installations. You only need to focus on things that are specific to your business.
Right.
And that's kind of logical. Like that's how it should be.
Right.
And that's why public cloud started to grow, right?
Right.
And a lot of applications and a lot of teams are designed with the public cloud in mind. Cloud native applications, cloud native teams, if you will, developers using public cloud tools. They are using Terraform to provision their infrastructure resources. So for some businesses, it is they cannot be in public cloud only. They need to be hybrid. They need to have something in public cloud, and they need to be something on premises.
Right.
Now, it is hard to apply two different methodologies for your two parts of the infrastructure. The on-premises infrastructure should be no different from the public cloud, because we all have seen that public cloud is this convenient experience. Now, when DevOps engineers they use multiple public clouds, they still have similar experience.
Right.
Amazon and Google Cloud, two different providers, but very similar experience. They can deploy same applications in both places. They can use Terraform with the very similar constructs. But when they bring into the game their third type of environment, their on-premises environment, it is so much different.
And we won't make a judgment on better or worse, right? I mean, the answer obviously in our conversation, it's kind of saying it's not as convenient. It's definitely not as fast. But I like to hear the rest of what you want to say about that story.
Yeah, and I don't want to even call better and worse, because like for a lot of use cases, traditional networking is doing a really good job, and we're there's nothing wrong with traditional networking. It's great. It's okay for its use cases. We specifically focus on these other use cases that are related to cloud native DevOps engineers.
Mhm.
Now, in public cloud, these DevOps engineers, when it's a normal situation for them to go into console, create a new VPC networking, and throw a bunch of virtual machines into that VPC and run something that can be an experiment, that can be a production, that can be small production that they will scale in the future. But everything starts with the VPC networking, and creation of VPC takes just seconds.
Right.
VPC networking, what is VPC? It's this little window which says VPC name, VPC subnet, do you need NAT? Yes, no, and create or cancel. This is what networking is from DevOps engineer perspective in public cloud.
Mhm.
And imagine they work this way for a few years, and then their business people say that there is a business reasons that they need to also deploy this new on-premises location somewhere, not in the public cloud, but somewhere else on premises. They
Mhm.
go to on premises thinking VPC and Terraform, but what they gonna face? They gonna face, ticketing system, email, and phone.
They're gonna face with like VLANs or whatever overlay that you use.
Yeah, they gonna appear in a whole different world where they don't even speak the same language.
Right. Right.
Uh, so what we do, we create uh, we have created Netris. Netris is a software that enables network engineers to create network that provides DevOps engineers the ability to self-service, just like in the public cloud, where network engineers are able to mark resources, say this bunch of resources, we let these DevOps engineers to manage this bunch of resources. And then DevOps engineers can easily go to Netris console, web console, or they can use Terraform, whatever they like to use. And very similarly to public cloud, create a VPC-like constructs and get these constructs provisioned and ready to use immediately.
Yeah. So would you say Netris kind of provide this abstraction level to make the networking more declarative rather than procedural?
Yep.
So by declarative, we're saying, hey, do you want BGP? As opposed to like true or false, right? Yes or no, you want BGP versus the procedural say it's a Cisco box, it's a Nexus OS, so you need to config T, router OS, router BGP, ASN, whatever. So I think that's what you're saying, right? Like Netris provides this abstraction layer that have with on-premise networking with the same experience as in cloud, like public cloud networking.
Yeah, exactly. Abstraction and declarative interface, those are the words that we like to use because there's no this one-to-one thing.
Yeah.
Some uh, some traditional network vendors, they what they do, uh, they do kind of one-to-one mapping of CLI commands into Terraform language. Uh, there is definitely a use case for this, but that's the cloud native use case is not like that.
Mhm.
You can do one-to-one mapping. You want abstraction where you say, I want NAT, network
Yeah.
address translation, and like I don't care how it works.
Yeah.
And it's up to Netris to figure out, okay, on which devices I can configure NAT? How do I organize high availability of these NAT boxes? And same applies to all other network services, like all kinds of layer 2, layer 3, layer 4, and BGP, all that things that are kind of essential to make your private cloud work.
Right. Like if I'm a DevOps engineer, I don't really care about VLAN. I care about isolation. I care about, I don't know, separation of concerns between the server team versus the firewall team. But I don't really care about the exact commands. I care about the product or the end results. And Netris
exactly.
provides that separation layer. So you mentioned Netris is a software that you run and provide this abstraction layer. You talk to Netris instead of talk to the boxes directly. So is this a software that runs, I assume it's on-prem, right? Because it runs in a VM, runs in a physical box. How does it run typically to manage your on-prem devices?
Netris controller, not to confuse with SDN controller. That's
no. SDN movement has died. Haven't you heard? No, just kidding. No, I mean, I remember SDN controller, but maybe like 90% of the people listening don't. But yeah, so Netris controller.
Well, I mean, there are definitely use cases for SDN controllers, and now there's also intent-based networking, right? And there are many good use cases for intent-based networking. I'm just saying, we don't do this. We do VPC type networking, which is different.
Right.
We may not have a lot of features that either SDN or IBM provide, because those two technologies are created for different use cases. Now answering the question about Netris controller.
For sure.
Netris controller can run pretty much on any Linux machine. The installation process is very easy. You get one liner, you just copy and paste into almost any Linux machine. And in a couple of minutes, you'll get Netris controller up and running. What will happen behind the scenes? That one-liner will install a tiny K3s cluster, just one node cluster, and will download containers, because Netris controller is containerized application.
Got it.
That way, it is easier for us to develop and deliver to our customers.
For sure. Okay, so you have a one-liner that allows them to create a Kubernetes cluster with a node, and obviously you have the pods and so on and so forth. But the controller, and then now you get it up and running, right? Like then you're able to do you provide a GUI for people to get in and start configuring, adding devices?
So most of our customers are either building a greenfield data center, or they are larger enterprises that already have something, and they are building like a little cloud native island. So building like one or two racks of something new. So everything starts with planning, right? They go to whiteboard and they draw, this is how many servers I imagine to have, this is how I'm gonna connect my upstreams. Those are public IP addresses that we've got. And based on that drawing, they go and order hardware.
Right.
Order hardware, order cooling, power, and rack space. Then before even they rack and stack hardware, the first step is to get Netris controller ready. That's for that our customers usually use a 1-unit server. They rack and stack that 1-unit server. They connect a management internet connection right into controller. Outbound internet connection connects directly into Netris controller. Then they install Netris controller with the one-liner, and it provides access to blank controller. Then network engineer role goes into Netris controller, and remember that whiteboard drawing and that list of IP addresses. Now we need to translate that from whiteboard and spreadsheets into Netris.
Got it.
So we go to Netris IPAM and we say, here's our public IP addresses, here's our private IP addresses, and then we have this topology manager where you point and click to define all the devices. This is my switch 1, this is name of switch 1. Netris will assign IP address and AS number automatically, things like that. Then you draw your topology. That's one way of doing through GUI.
Sure.
But we also support, we also have Terraform provider that's a validated Terraform provider with all the documentation in a Terraform registry. So network engineers also can benefit from using Terraform, and they usually do. So they can use Terraform to describe that topology in a declarative way.
Sure.
It's a minimal information that goes to Terraform, like list of the switches, and you need to describe how you imagine to connect links, like which port connects to which port.
Sure.
And you can even use Terraform loops to describe that. Because if you have like 20 switches, the way you connect your leaf switches to spine switches is probably very repetitive. And you can describe that in 4 lines in Terraform. You put that 4 lines, you do Terraform apply, and then you see this topology pops out in a Netris topology manager. When you get there, you just take that topology view, you go physically to data center, and then based on the diagram, you start reconstructing your switches.
Or better yet, you pass it on to some data center pork chops. You cut a ticket, and you say, hey man, when you have some free time, which is never, you go ahead and rack and stack port 1 to port 16 on this guy, and so on and so forth.
Yeah.
So how does so you mentioned 2 ways, but there somehow needs to correlate like switch 1, right? Like switch 1, you need to physically map that into this physical switch in rack 1, top of rack, this guy, right? So how do you bootstrap that? Is this still some sort of manual work in the beginning to configure management IP, host name or whatever for them to be discovered? Or is that bootstrap could be done by Netris as well?
Right now in current release, we require to install the operating system and copy and paste one liner from Netris controller into a switch. So that one liner has a unique ID inside, and when you copy and paste, that's how we identify which switch is that.
Got it. No, go ahead.
That's the motion for today. But we're currently working on what we call zero-touch provisioning. So, so basically, you will be able to provide the MAC address, and we will identify the switch based on MAC address, and we will install the operating system and the Netris agent automatically.
Nice. Yeah, no, I mean, the only reason I asked is because you mentioned spines and leaves and class network, right? So like I think one of the biggest thing that we used to try to figure out is how do we even abstract that, like zero touch provisioning, as you mentioned. So we know the MAC address on the management interface, and we know kind of this inventory label that they help us. So maybe you could just like scan it in and inventory label, then you do your DHCP server, and then so like the IP address, right? Like so those could be deterministic and then go on, and then we could offload those labeling and inventory to the vendors, for example. Then they could ship it to us in a container already, where inside of like what I'm talking about, like big truck, like big containers where it's like 20 racks and then 10 racks of compute, 10 racks of database or whatever. So that's why I asked. And so it's great that you're moving toward that direction and zero touch provisioning. But those actually came in. I would say those really only applies to large enterprise and maybe cloud providers. most people, they're happy with just the one-liner. Like you're already saving so much work. It's like, oh my God, I'm already like 90% done. That I don't care that I have to copy and paste in the console for just this one thing 20 times.
Yeah, exactly. This is more of a to make to give it really great experience.
Yeah.
And oftentimes the person who reckons tech and person who can install the operating system are different people.
Mm-hmm.
So we imagine that in the future we will have a mobile application for the data center engineer. So
Mm-hmm.
data center engineer doesn't need to take a laptop. They take mobile app and they will see that topology view in mobile
Yeah.
app,
Yeah.
and they will be able to tap on switch like, hey, I'm rack stacking this switch in this
Right.
rack.
Right.
They tap on it, and then it will request access to camera. And like you
Yeah.
mentioned, there is this tag with a barcode that shows the MAC address.
Right.
So engineer will just scan that barcode like in a supermarket.
Yeah.
They scan the barcode, and automatically based on that barcode we will identify the switch. That's where we go, and that's why we need that zero touch provisioning.
Oh, I'm so ready for that. I mean, it's so cool. Like, I mean, it would have been really cool, right? Because not a lot of people, not a lot of company could exert that sort of pressure or that sort of demand power for your server provider, right? Like, I mean, there are some people who could say, "Hey, just ship us 50 racks, all labeled and all all cabled up, and then you just provide the patch panel on the side of that container, and not Kubernetes containers, right? But like actual physical container.
Physical container.
Yeah, physical container where you just okay now you just need 16 uplinks to these big switches on the core switches, but then the rest of the 50 racks is already cabled. Not many people could do that, and I think that's where a lot of times when I talk to my cloud provider friends, they kind of live in a bubble. They're like, "Oh, why don't you just kind of take it to a data center tag?" And you're like, "No, like 90% of the world don't do that." So I'm glad. That almost sounds like magic, right? When you describe it, we know it's very real, and it just takes time and energy to code it up. But everything else, like the tech stack, is already there for you to do. So I'm really looking forward to that. If one day you could do that, I'll be the first to like retweet that video or whatnot. Like, man, this is what I should have in 2012 or whatever.
Yep, we're moving closer to that.
Nice, nice. I'm excited for it. So, can you tell us? So you mentioned it's a Kubernetes, container image that you pull down, and but obviously, when I looked at your demonstration videos, it does show, like a front end, and obviously you need some kind of GUI for people to click and drop. And can you share some of the technology that you use? I mean, I don't want to no secret sauce, right? Just whatever you could disclose on, this is what we use as front end. Maybe we use some sort of, web server and so on, database backend.
Sure. So the backend controller backend is developed using Node.js.
Okay.
Front end is a
Oh, no, just kidding. No, like I'm a Python snob, right? I guess you could say that. So, but okay, Node.js it is.
yeah, that's backend, and it is a API first type thing. So backend has all these APIs, and front end is using these APIs, but also our Terraform provider is using that APIs.
Yeah,
Our Kubernetes operator is using the same APIs.
for sure.
There's also agent that's only front end back end controller part.
Yeah.
There's also part of Netris agent. That is, agent is little piece of software
Process.
sitting
Yeah.
inside the switch.
Sure.
That is developed in Go,
Okay.
Golang, because we need something that is high performant.
Sure.
Because some switches they have performant ASIC, but they have small CPU, so we need to be cautious about CPU resources. So controller, besides front end, back end, it also has this gRPC server that is for network switches and soft gates. I will tell what soft gate is soon. So network switches and soft gate nodes to connect to controller using gRPC. So this part is written in Go.
I see.
Softgate is I mentioned Softgate. It's a Linux machine with a SmartNIC card with a DPDK accelerated software. So Softgates handle networking part that switches cannot do. Switches provide high performant connectivity between your servers and other servers, between all your servers. But when you need connectivity with the outside the world, when you need network address translation, you need layer 4 load balancing, you need site-to-site traffic encryption, like site-to-site VPN, and border routing functionality. If some of our customers, they plug directly into internet carriers or internet exchange points, and some of our customers, they use Cisco or Juniper routers as upstream because they already had that, but other customers are not using that. They can use Netris Softgate, and this DPDK accelerated Linux machine can forward 100 gigs per second of traffic as a border router. And the beauty of this solution is that you have the same machine for border routing, for layer 4 load balancing, for NAT, and site-to-site VPN. It's not 4 different machines. It's one machine providing all these functions, and you can scale that machine horizontally. You can do HA. It's very similar to how these big cloud providers do under their hood.
Right. But that Southgate machine is actually a physical machine that either you buy and ship to the customer, because it does require DPDK and SmartNIC or whatever that's on board, right? So is that something that white label, like, i.e. the customer could say, I'm going to buy this Netris Southgate compliant box, and then I just install the software? Or is it a combo deal where it's a Southgate, model 1, 2, and 3 that I just order from you?
Good question. We're trying to be neutral, and we do have system requirements, because this is forwarding 100 gigs per second in a 1 unit server. That's a big deal, and it needs, the server needs to have 128 gigs of RAM, needs to have 2 modern CPUs, 2 actual sockets with minimum 8 cores in each socket.
Right.
Needs to have minimum 100 gigs per second SmartNIC, and we have kind of few SmartNIC models that we have validated. Theoretically, we can support just any SmartNIC, but we like to validate things so we can tell our users, hey, this is validated. This definitely works.
Right.
So then they buy just any servers, Dell, HP, Supermicro. SmartNICs are, usually they buy NVIDIA SmartNICs, because they are just, I don't know, popular and performant.
They're the first, right? Like, I mean, they invented the term, what is it? DPU, data process unit, versus like GPU and CPU, and
Yeah, that too.
So nobody else could use that term now. But so anyways, people use the same thing and just call it different.
Yep. So that's current situation. Besides, uh, we're uh, uh, we're planning to come up with a reference architecture with a couple of vendors.
Yeah.
So it will be kind of set of switches, softgate hardware, and compute hardware. So users will have all these components. We only provide software. We're not going into hardware reselling business. No, we're just software company.
Yeah, for sure. So that's interesting. So you're purely a software play, even though you're actually dependent on, some sort of hardware. Of course, right? You got to forward packets, and
Yeah.
but you do provide, validation, certification, these NICs that work well. Not to say it won't work with other NICs or DPDKs or whatever, but these are the ones that you validate it and you give blessings on.
Yeah, because the way the way we think about why do we charge our customers, what we like to describe in this way, that our customers are not paying us just for using Netris software. They are paying us because for the experience. We as a company, we feel responsible for the whole experience.
Right.
And in order to be able to deliver on the experience that we wish we deliver, we need to validate all these things.
Right.
And we do a whole bunch of different layers of validation. We use some data that is coming from our users. We run thousands of tests in our environments, a lot of automated tests on different hardware with different configurations. We run different failure scenarios, like this cable failed, that device failed. We need to do all these things to ensure that we can provide users with the right experience. And after doing all that, we feel legit, charging for the experience.
Nice. I like how you emphasize the experience. That reminds me of Apple, right? Like, I'm not paying just for this laptop. I'm paying for the actual Apple experience. my iPhone experience. That's why they charge 30% more than whoever else that's out there. But no, I'm just kidding. I totally agree. I think you are paying for the end-to-end experience, right? I mean, I personally use Django, which is like a Python framework. I don't pick it because it's current features only. I pick it because I trust that whatever you roll out, Django 4.0, it's going to work with all the packages. It's going to work with all the plugins and that you certify that will work. And I won't get caught off guard with, incompatibility like I would get with WordPress or whatever. So I do trust that. And I think that's very valuable, especially in the enterprise world. Like, they don't have the time or energy or the resources to go test 10,000 solutions. They want to be able to say, here are the 4 solutions that you certify with, and I just, out of these 4, I trust your opinion on, these 4 will be cover 80% of the use cases, and I pick one of them that's most suitable for me, whether that's because of budget, because of engineering resources, or whatnot.
Yep. But by the way, we for the product itself that goes into customer premises, that's the agent and softgate. Those high performance parts are developed using Go, and DPDK accelerator is C and C++. But we do use Python
Okay.
for some internal use. Our NRE engineers that run a lot of simulations to test the product.
Mm-hmm.
They use a lot of Python scripts. So, I mean, Python ecosystem seem to be really great for a situation where you need to do a lot of experiments, lot of testing, a lot of changes.
Yeah, like
NRE
quickly.
people make changes every day because every day they get new builds from developers with some new features, and they need to tweak their NRE testing part differently,
Yeah,
right?
yeah, yeah. Yeah, for sure. I think Python is great for. I mean, I'm just kidding. I mean, of course, you pick the best tool for the job, right? Like Python is never going to be as fast as C. It's never going to be as fast as Go. But it has its own other strength, right? Like you said, it's quick to prototype.
Yep.
It has a good ecosystem. So it's obviously it's not a popularity contest, but being popular means the bug gets fixed quicker, gets discovered quicker,
Yep.
and so on. So those are its strength. So definitely. So you mentioned, you're a software play, and these are all shipped over in different parts. That whether it's the agent, whether it's Southgate, or whether it's the controller, how customizable or how expandable, right? Like if I find something that's not within the current controller, or if I wanted to add some features to the agent, what are some of the ways that network developers that just say could interact and could enhance that feature and maybe merge upstream back to your code?
Um, so our controller API is fully open, and we and normally documented.
Okay.
So some of our customers uh, they build their own product, like they want to embed Netris into bigger product that provides some kind of private or public cloud services. So
Mhm.
they consume our API, but we run the switches and Softgate nodes.
Mhm.
Uh, Softgate and switch agent software is currently closed source, but we're planning to open source API on that side too in the
Oh, no
future.
kidding. Okay.
Yeah, there's some work that we need to finish before it's good for open sourcing, but
Yeah.
eventually we'll get there. So we want people to be able to make little tweaks into agents too.
Nice. You heard it here first. Alex just promised that he's good. No, I'm just kidding. No, I mean I'll settle for APIs, right? Like, I don't even care whether at this point whether it's open source or not. I just want to be able to say, these are the stuff I want to process externally, and I could still somehow communicate with either the controller or Southgate or the agent. But like you said, it's you did mention that it's a API first, right? So like the whatever you talk to the controller, it's the same thing that the front end talk to it. There's no backdoor for the controller to access the database or whatnot. Everything is API first.
Yep.
So I think that's great. That's how modern networks, how modern tools have become. It's always API parity. There's no like backdoor. And I think back to what you were saying about the public cloud really changed that, right? Like, do you think uh, I don't know. Do you think EC2 has some backdoor to manage SQL? No, right? Like it's all each team stands out itself within Amazon, and each of them, creates talk to each other through the APIs, and that's how they were able to roll out services so quick. There's no backdoors, and everything's API first. So cool, man. I like that very much.
Uh, yeah, I'm. It's cool that you brought up this example specifically because
Sure.
we're currently working on compute and network interoperability
Yeah.
API,
Yeah.
and we're developing that API in a way that it will be standard. It will not require any backdoors.
Right.
So currently, right now, as a prototype, we're doing this for just a one compute provider. But in the future, the design of API will be the way that any compute platform, like be that VMware or be that Red Hat OpenShift or Rancher, whatever it is, they will be able to plug into that API, because the goal is to make switch ports disappear for DevOps. Remember in my example that in public cloud, DevOps engineer creates this VPC and throws a bunch of virtual machines on it.
Right.
We need to replicate exactly the same experience on premises.
Mm-hmm.
But today, even though we make it incredibly simple, DevOps engineers still needs to select from the list of switch ports that network engineers allow them to.
Right.
That's super simple. It's just 3 clicks. But we want to get rid of that too. So how we envision it be that there will be the process where DevOps engineer will create new VPC, and that new VPC will automatically show up in your compute environment, like your VMware or your Rancher or whatever it is. When you open networking there, you will see the network that you have created in Netris. And when you request your virtual machines, Netris will automatically understand behind which switch ports are these machines happen to be connected, and will dynamically provision the underlying physical network for that.
Nice. That's pretty ambitious. I mean, because I think the difference between AWS and on-prem is AWS abstract all of this from you, right? Like you don't even know what the switch is, but on-prem you actually know. So it's a little bit harder for you to say, I want to duplicate that experience completely, and it's different. But I like that goal. It's audacious and it's pretty strong goal to shoot toward, definitely. And also, by the way, don't take my word for it. Like API first in AWS, right? Like go back to I believe it was 2003 that Werner Vogel from Amazon actually came in. I mean, there were a bunch of articles about him talking about like he came into Amazon as CTO and starts mandating API first as the way to do things internally. And he had the full backing of Jeff Bezos, and that's why in 2006 they're able to launch S3 so quickly, and the year after EC2, and boom, like the 10,000 other services came after that. It's because of that vision in 2003 that he came in and say API first. So don't take my word for it. I'm just a messenger.
No, that's how you build your product in a modular way. So you have kind of few small teams, and each small team is responsible for one aspect. And when there's this API and containerized product, it's so easy. Each small team can work as a small team. That's important.
Yeah.
When they get bigger, they say what one engineer can do in 1 month, 2 engineers can do in 2 months.
Right.
Yeah.
And then the 3 would be like 5 months, but
yeah,
because they have to discuss design patterns, and they have to get agreements and so on. But no, I see what you're saying.
Yeah. There's actually math research behind that, and there's math formula how you can calculate that complexity. It's
pretty fascinating, isn't it?
Yeah. So you wanna preserve, you wanna stay nimble.
Yeah. So I mean, I don't mean to just be like a spew on AWS, right? But they do have this thing called the pizza team, the one pizza team, right? It's like, oh, your team needs to be small enough that you could feed everybody with one pizza. But of course, this is just a goal. I mean, I'm pretty soon. I mean, even by the time I was there, like it's 2 pizza team. Like there's just no way. Some of the teams, I mean, you want to just make that person die or what? Like, there's just no way. But it's two pizza team, and it's just an idea, right? Like that team should be small and nimble enough, like what you said, Alex, that
Yeah.
they were able to reach things fast and try things out fast and potentially fail fast and fail forward.
Yeah, actually, we found that peer reviews and continuous feedback is critically important. So through trial, error, and learning, we currently like to keep each our team at the size between 2 to 5 people. So
That's still one pizza team, unless you have somebody who's a big eater. Like me, I'm a big eater.
Yeah, that way, we try to keep like groups of people that are between 2 to 5. If one team grows bigger than 5, we usually separate them into two functional groups, and we have this culture of feedback and transparency. So when someone does something or plans something, we always ask each other for feedback. For feedback, for peer review, kind of like open source development culture is.
Right.
So that helps a lot.
Yeah, I mean, I agree. I think it's good to have that feedback loop, and even sometimes being brutally honest, right? Like, if you can't be honest with internally, then the first thing you do is just like, would you rather like fall on your face in front of a customer, or do you want to have like some friendly conversation between colleagues, even if it hurts? Yeah. So Alex, I mean, one burning question I have is, it's your domain is netris.ai, right? So by the way, we try to register for some AI domain. That's actually I think a British colony top level domain. So all of them are super expensive. But anyways, so what's the AI bid for Netris? Is that sort of like go in the future, or do you actually have some sort of artificial intelligence within your software?
We don't have any deep learning technology.
Sure. Thank you for being honest. I mean, a lot of people would just start BSing, but thanks for being honest.
Yeah, no. Our algorithms are developed by humans.
Nice.
And tested by software that other humans develop.
Created, sure.
Yeah. I think the idea of AI here is more of that the algorithm that we have created is taking away this this stupid repetitive part of the work that no one really likes. Like I think about people like creative creatures, and like wasting creative creatures' time on repetitive things, that's not good.
Right.
It kind of feels wrong. So that's what AI does. It takes away the boring part.
Got it. No, I buy that. So it's like, I don't know. Hey, Alfred, go, go brew me some tea, go make me sandwiches, right? Like, because I need to focus on, I don't know, solving world hunger. So the AI part is the robotic that handles your repetitive tasks, so to free you up to do more creative work that as you're meant to be doing.
Yeah, and the way our agent works, the intelligence to configure network devices is not in controller; it's in agent.
Yeah.
So agent, every agent works independently. So every switch has agent, every soft gate router gateway has agent, and they communicate with controller, but they are not allowed to communicate with each other because we want to have stateless system.
Got it. Interesting.
To make it stable, we wish it is stateless. So they are not allowed to communicate directly. They need to learn all their information from controller, and the information that we store in controller doesn't keep implementation specific data. It's only either user-defined requirements or metadata coming from applications. So our agents, when agent boots up, agent has this understanding of environment, like, oh, seems like I just boot up in a switch, or I just boot up in Softgate. Okay, seems like I'm running this version of Linux, and seems like I have DPDK acceleration enabled. Okay, and okay, then I need to install this. I need to configure this, that, and that. So technically, it's a lot of if-else type, logic, a lot of algorithms like that, a lot of math. No deep learning, but like there is this notion of understanding of what environment do I live.
Right. Yeah. I mean, I was just playing. Of course, it's smart, and it's no like algorithm in terms of I don't know, natural language processing, right? But it is a self-sustained brain that you boot up, and you're able to be self-aware and start processing information based on your environment, and that is a intelligence by itself, right? Yeah. So let me ask this. I mean, we talked about Netris, we talked about all the agents. So how can people get started with Netris? Yeah, sorry to cut you off guard there.
You mean how to test, how to learn?
Yeah.
Test?
So how do you mean if people are interested in trying it out? How do people get started with Netris system? Is there a trial? Is there a way to get their hands dirty? What are the ways that they could get started?
That's a great question. And when I was working as a network engineer, I remember that every time that our management would decide to buy a new technology, or if I would decide to test one new technology, I would. There were always these challenges that if it involves hardware, you need to register with the vendor, you need to wait until
Buy a license.
or get license. So we decided to make this testing simple. On our website, there's this button, Try Now. You click Try Now, it shows you two options. If you happen to have environment, the switches and machines that you can use as a softgate, you can install Netris on-prem for free. We're not concerned of that. That's okay. People can use it for free. That's no problem with that. Or if you don't have environment, maybe you're in public cloud and you're thinking about greenfield deployment. You don't have hardware yet, or maybe you have data center but you don't have all the time to put together that physical app. So we have created a lab environments. We call them sandbox. So sandbox has 6 switches, 2 softgate nodes, has internet connectivity with the upstream providers with IPv4 and IPv6. Has a bunch of Linux machines that you can load applications on them and test. Has a pre-installed Kubernetes cluster where, again, you can load applications and test. So from the website, you just fill in this form, your email, your name, and we send a reply email with credentials and documentation. So you get access to Sandbox in 1 minute, and then you can try everything, read the documentation. We also have a Slack community. People join our Slack channel where they can speak with solution architects, but also they can speak with the developers. They can speak with other users too. And we are seeing sometimes people are like, hey, two different users asking each other some questions like what switches worked better for you, what cards you use, things like that, and or we or sometimes there's kind of very, let's say, very Kubernetes specific question, and our architect who knows like ins and outs of Kubernetes
Yeah.
at very deep level may answer this person immediately. So we're trying to create that nice community of professionals within Netris.
Nice, nice. That's very frictionless, right? Like if you just provide a sandbox, then you're I don't know how much easier it could get. Like it's just like all you need is a browser and some ability to click your mouse and yeah, no, that's great. Yeah, I know. I did notice that all of your netris.ai/videos link at the end, you always say, Netris is easy. Here's why you try it. So I like that. You must be trained well by your marketing, person. It's like, hey, Alex, every time you stop, you gotta do this tagline to enhance people's memory on it. And it stuck in my mind, right? Like I watched 4 videos in a row. And by the way, I think your team is very Kubernetes based. I mean, we didn't get too much into it, but it's deep knowledge. It's obvious that very Kubernetes focused. I didn't even know Calico CNI could actually establish BGP directly. So yeah, definitely check out Netris. Join the Slack community, try it out. Where can people find you on social? Do you have obviously you have your Twitter handle up there, and where else? LinkedIn maybe?
Yeah, I'm active on Twitter, LinkedIn too, and on Slack, always on our Slack.
Yeah, nice, very cool. So we'll provide all the links within the show notes, of course, and obviously you could find all that try information on Netris's homepage, which is just netris.ai. So, hey, Alex, I think we're coming up a little over the time, but it's been very interesting conversation. I am surprised at how much detail you dive into on the Netris, the tech stack. It's always more interesting to me on how people came to here, and one thing I wanted to know more but didn't have time to is your business experience, right? Like, so obviously you raised some funds and seed money and Series A, and now you're trying to expand. So that's the area I think set for another episode if you're willing to share some of that as well.
Sure, looking forward to, and I very much enjoyed this conversation. It came across like a casual conversation. Sure, I'm looking forward to discussing this further more.
Yeah, absolutely. I mean, I don't know. I didn't even without that red light, I don't even think I was recording. I just like two nerds trying to discuss and talk about technology. So
Yep.
thanks again for being here. I appreciate your time.
Thank you so much.
Thanks for listening to the Network Automation Nerds podcast today. Find us on Apple Podcasts, Google Podcasts, Spotify, and all the other podcast platforms. Until next time, bye bye.